Hello, this is the Bullis Student Tutor, and I'm doing a video on polar coordinates. So to start, I think it's good to review Cartesian coordinates. So Cartesian coordinates, that's just in the xy plane, you pick a point based on its x and y position. So the x position for this point would be 6, and the y position would be 4. So in Cartesian coordinates, this point would be called 6, 4. The x is 6, the y is 4. In polar coordinates, we're going to re-express this point, except instead of using x and y, we're going to do something different. So we're going to take the distance from the origin to this point, and usually we denote that as r, and then we're going to measure the angle that it makes with the positive x-axis. This is normally called theta. And so to get r and theta, so if we say x, y like this, two important identities show up. So by the Pythagorean theorem, there is r squared is equal to x squared plus y squared. And SOHCAHTOA says that tangent of theta must be equal to y over x. So now these are two important identities when converting between polar coordinates and Cartesian coordinates. And it should also be noted that, of course, we could have used a different point. We could have had a negative x, a negative y. We could have had both negative x and negative y. And all of these identities should still hold. Okay, now let's try converting a point, negative 2, 2, for example, from Cartesian to polar coordinates. The reason I didn't use the last point was because the last point would be very hard to get a nice angle for. We would have a kind of weird angle. So this is better. You first want to find r squared, or r actually. So r squared is equal to x squared plus y squared. This would be equal to negative 2 squared plus 2 squared, which is 8. And then r must be equal to the square root of 8, which can be simplified to 2 square root 2. So that's r. Now theta, which would have been harder in the other example, will be pretty easy here. So we first have to write tangent theta, and we know this is y over x, which would be 2 over negative 2, which is negative 1. And we could, of course, arctan both sides, but we need to remember the angles that we're working with here, or the quadrants we're working with, sorry. So in this case, it's best to draw a quick little sketch. So we have a point right here, and of course, if we find the arctangent of negative 1, we get this angle. So we have to add pi to get the angle that we want. So if we arctangent both sides, we know that we are going to have theta is equal to negative pi over 4. But in order to get the right quadrant, we must add pi, and we see this is going to be 3 pi over 4. You should take note that I am working with radians. It is standard to work with radians, of course. We could use degrees, but it's usually we would work with radians. So we can write this point right here. We can write this point as, in polar coordinates, 2 square root 2, comma, 3 pi over 4. Okay, so now we want to graph polar coordinates. We use this grid. This is very convenient. We have r as the radii of the circles, so that any point on the same circle will share the same r value. We write 1, 2, 3, 4. Those are the different radii. Those are place markers. This point here we see is going to have an r equal to 3 because it lies on the circle of radius 3. So if we started to write this point out, we have 3. And then the theta, we just divide the circle up using these different lines. And we could easily see that this angle here is just 7 pi over 6. So that theta is 7 pi over 6. And of course, any point that lies on this line stemming from the origin will have theta equal to 7 pi over 6. So now that we have a point graphed, we have 3, 7 pi over 6, it would be useful to know how to convert this back into Cartesian coordinates. And to do this, we just use some basic trig identities. The definition of cosine and sine. We know that we can find the coordinates on a circle, which is how we've graphed our point. We can find the coordinates based on the radius of the circle and the value theta as follows. So hopefully you're familiar with these equations, with these identities. So they're very useful for converting between polar and Cartesian coordinates because if we wanted, for instance, to write this point as a Cartesian point, we would know that x is equal to r, which is 3, cosine of theta, which is 7 pi over 6. Y is equal to r, which is again 3, sine of, again, theta is pi over 6, or 7 pi over 6. And then we can find x and y. So this is just 3 root 3 over 2, or sorry, negative 3 root 3 over 2. We have negative cosine. And then we have that sine would be equal to negative 3 over 2. So our point in Cartesian coordinates is negative 3 square root of 3 over 2, comma, negative 3 halves, and we're done. I hope this video was helpful. This was a basic overview of polar coordinates, and it was brought to you by a Bullis Student Tutor. Thanks for watching.